Okay, let's have a class, and we will talk about a very important concept, which is lipids oxidation. Okay, so we're using a chalkboard talk today, talk about all the details. So lipids oxidation. So first of all, what is that? What is we're going to talk about in the for the chemistry class? Talk about the lipids oxidation. We will talk is calling auto-oxidation. This is specifically we talk about is fatty acids in food products spontaneously reacted with oxygen and will generate a mixed compound. Basically, they are aldehyde, could be ketone, could be alcohol, it could be some polymers or dimers from free radical, and it could be many other chemicals. Now, what's the results going to causing? Which obviously is the deterioration of the food products. We gave them a terminology called rancidity. Now, what is that? We gave you a very simple example. Two examples. Number one is lard, fatty acids from pig. Lard is become sweet. The second example is you vegetable oil. Let's say you have a soybean oil. It's gonna become fishy and become beany. You can smell it, you taste it. It's very weird. These are the example of auto-oxidation. Now here is the first question. Based on the definition, we say it's a fatty acids reacted with oxygen. So there's a very simple question. How about we deleted all the oxygen? Theoretically, yes. Practically not, because we need oxygen. Sometimes the oxygen will working with some of the color ingredients will show in the color, let's say myoglobin. So practically impossible to delete all the oxygen. And also, they could generate different type of the oxygen, like triplets, singlets, and atmosphere oxygen at different level, and a different formation. That's what we will mention. So this is what I want to say. Very easy. People think about we want to take in the oxygen, but practically it's impossible. Now the second question is, what are going to be the factors to impact the lipids oxidation, or we say it's auto-oxidation? Now obviously, number one, the presence of oxygen. We'll go detail that. Second one is the saturated, unsaturated, or we say saturated fatty acids, the ratio. Number three we want to mention is, of course, the double bonds, the number of double bonds. And we also want to mention the location of the double bonds. It is also important. Number four, the presence of some of the pro-oxidant. There's something which is pro-oxidant will trigger the lipids oxidation process. And of course, we're going to have sometimes exist in some of the antioxidants. This we will mention on Thursday. Today we only briefly mention. Okay, how about the others? We care about whether there is a light, whether there's a heat or maybe a metal ingredients in a food product. It's going to also impact the lipids oxidation. Or the other one, packaging. The packaging, how we do the package? We do vacuum package, aerobic packaging, or like PVC packaging, or modified atmospheric packages. They're also going to impact. Okay, so briefly we want to talk about is all these factors. Okay, now we're going to mention about the general steps. Then we will go detail using oleic acids as an example. So first of all, what are the general steps? General steps of lipids oxidation. First one, we will generate a free radical. So release one proton or maybe hydrogen ions will generate a free radical. So first of all, what means a free radical? What a radical means? The centerpiece of we talk about radical is they have unpaired electron. Then it will become a free radical. So the beginning what you're going to have is a free radical generate. This stuff we call it alkyl radical. Now once the free radical generate, it all going to depends on what the location of this double bonds, if it's unsaturated fatty acids, and how easy it will come up. So for example, I had a double bonds right here. And then I have another CH2 which is very close to the double bonds, and this position I call it olefinic carbon. This carbon is very easy to involved in the lipids oxidation. Very easy to generate a free radical. Now why? Because the energy is low, is around 85 kJ per mole. But then you have a question, how about these saturated fatty acids? These saturated fatty acids chain also will have lipids oxidation. Does not mean it will not happen, but compared to the unsaturated fatty acids, the double bonds, it is relatively difficult to do because the required energy is higher. It's about 100 to 105 kJ per mole. Okay, but does not mean it's not going to happen. Now we want to mention later on there's some other structure it's more easy to have. And the second thing we also want to mention is when this alkyl radical comes out, this double bonds most of the time will happen is a shifting, or sometimes we say migration of double bonds. Therefore, it will generate isomers. So we'll give you an example to talk about that. Okay, so that's the first one. Generate free radical. What's the first one? What's the second one? When we have this free radical generate, it's going to react it with oxygen. We already said it, oxygen is important. So we'll generate the oxygen. Will become ROO like this. What is this called? Peroxy radical. We will mention about this oxygen some later on. Okay, that's a very tricky one. Once we have this ROO, peroxy radical comes out, it's gonna be not stay there. This guy is very energetic. it will be reacted with another chain of the fatty acids. So what's going to happen? It will generate is a OOH, and then is another new free radical. So here's OH is usually a fatty acids in another chain of triglycerides. If it's a triglycerides, or maybe another free fatty acids in a food products. Okay. Now they generate a new free radical. This new free radical will do the same thing, like this, to react it with oxygen, because oxygen everywhere, then become perioxy radical. So what we're going to have, this product's going to have accumulated. This is hydrogen peroxide. Therefore, we usually call the first step is initiation, and then the second step, because it's subtract a free radical from a new fatty acids, we call this is called propagation, which means looks like a chain, make it longer and longer. Okay, what are the third step? Of course, it is called termination. So what is going to be the termination comes out? Termination will come out in three different situations. So our free radical with another free radical will generate a dimer. This is the first situation will happen. Then the reaction will be stopped. The second thing will happen is a free radical become a perioxy radical. Then lots of the perioxy radical will react it, become a perioxy radical polymer. Now the last situation is you have a free radical, then you have a perioxy free radical, they will be combined, then become ROOR. What it is called? This will called alkyl and perioxy radical combination. Now we have three types of the situation. Either of these reactions, it depends on the concentration of the oxygen. Usually in the atmosphere, oxygen, which means you have a certain amount, it usually happens is the last one. In a low oxygen, you usually going to happen is a dimer or polymer will generate. So give you a very easy example. In a frying oil, when you cook, you're using frying oil, you fry. Later on, the oxygen is gone. Then what you're going to find? The food is very sticky. The food becomes gummy. And the food becomes viscously. These, which means the polymer is generated. And at this moment, it's very low concentration. Okay? Very low concentration of the oxygen. Now here, we want to spend some time talk about this oxygen. And it's very important you need to know. Does not mean all the oxygen will be automatically has some of the lipids oxidation. There are different formats of the oxygen. It could be, we call it O3, which is triplet. It also could be O2, which is atmosphere. Once you have a triplicates, when you have a triplet oxygen, what's going to happen? Remember we talked about the electron? Their electron in the 2p is like that. It's separated into two orbitals. And this is not going to fit Pauli exclusion policy. Because Pauli exclusion policy, which tells you the electron in the same orbital, which is running opposite direction. So at this moment, if this happens, these type of atmosphere oxygen also could be like that. These type of the oxygen, they are low energy, they are not very active as a free radical. So it will not be directly to take off a new free radical from a new fatty acids chain. It's not going to happen. So how they happen? They are at the beginning, they will react with the existing free radical, become a perioxy radical first. They will not do this immediately. They will do this way first. Because perioxy radical is a very energetic chemical. They could react with any of these electrons in the double bonds. So this is the first thing I want to mention. Now, I just said at the beginning, this oxygen, you want to remove it, it's difficult. Even you remove it, sometimes it's still going to happen, the fatty acids reaction. So oxidation, why? Because these chemicals, the O3 and O2, in a food products, they could become from triplets, become singlet, which is we just say O2-1. Once it's become a singlet, then it's going to be follow Pauli exclusion policy. So the two electrons running in the opposite direction in the same orbital. And when they form in the singlet oxygen, actually there's a 4 different types of the oxygen going to have. This is we call it a delta 1. Now why do we have this happen? Because in our food products, more or less we have some of the photosynthesizer. What are they? Chlorophyll, myoglobin. And our food products, more or less, will expose to some kind of the light. More or less will have a little bit of heat. So that's the reason you will have, even if you do vacuum package, even if you do a modified packaging, the triplet oxygen existing there, you have a photosynthesizer, you expose to the light, you're going to have a singlet oxygen going to come out. And this singlet oxygen comes out, it will speed up the lipids oxidation. Not only for that, it will also forming the isomers. So we will mention several examples. Okay, the isomers, which is related to the shifting of double bonds and the migration of the double bonds. Okay, so this is the overall we talk about is general steps. Now next, I want to give you an example of how we talk about, how we discuss about the lipids oxidation. Just an example. That's example very typical in the textbook everywhere. So what is that? We were using oleic acids as an example. So where that comes from? we gave you an example of sunflower oil. What's a sunflower oil? The triglycerides looks like. C, C, C. We have H, 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 and H. So we have O, 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 and we have CH2, CH2, and CH2. Okay, remember, we talk about stereo specific number 1, 2, 3. The first place, usually it's stearic acids. So CH2 will directly write 17 or 16, and then CH3. That is SN1, stearic acid. The second location, it is CH2, 6, then CH2, then CH, double bonds right here, CH, CH2, then CH2. This will be carbon number 8, carbon number 9, 10, 11. This here we are adding about 6, and the last one is CH3, a methyl ends. What is the second one? This SN2 is oleic acids. Now what are the last one? The last one, CH2, 6, CH2, CH double bonds, CH3, CH, CH, CH2. So here will be 8, 9, 10, 11, 12, 13. And goes here, we'll have 4 and CH3. This SN3 location is linoleic acid. This is the structure for sunflower oil. We will give you an example. We'll take from here. Okay? So let's say a sunflower oil is put in the room temperature way too long, maybe a year and a half or 2 years. Started to have rancidity, not smells very good, tasty, beamy or fishy, or whatever we call it a rancidity. So what's going to happen? First step, this guy is going to come out. CH, CH, CH2. Okay, I skip all these. This is carbon number 8, carbon number 9, carbon number 10, and carbon number 11. Now, you should know, they're going to generate 4 different type of the isomers. We're only going to give you a first example, which is, remember what I said, olefinic, the position of carbon 8, which is the closest one to the double bonds, it is very easily to be reacted and then become a free radical. So what happened the first step? This is gone, become a free radical. Okay, so this is called alkoxy radical. Okay, now the second step we're going to happen. You can do the same thing. CH, CH. I'm going to draw here 8, 9, 10, and 11. What's going to happen? Oxygen will be go there, obviously. So, oxygen 1, oxygen 2. Become this. Okay, what is that? Perioxy radical. Okay, once this is called initiation. This is called initiation. Okay? This is called propagation. Why we call it a propagation? Once this guy comes out, it's a very energetic chemical we mentioned. What they will do? This will go, might be here, to take out of a hydrogen. Okay, now once this happens, they'll cause some of the migration. Okay, so this is gone. This double bond goes here. Because peroxy radical is very strong, so they go to another chain of the fatty acids. In the sunflower oil triglycerols, they take it out. Therefore, here becomes a free radical. Is that right? This guy becomes a free radical. So linolenic gases become a free radical. Can go ahead to react with oxygen. This is we call it a propagation. Okay, once this gonna happens, what they gonna do the next step? The next step we are gonna be following here, because the oxygen is gone. You go there, you take out of the hydrogen from here, so it will become O, O, and H. This is a hydrogen peroxide. Hydrogen peroxide is very unstable. That's why the candidate, I told them, you have to store storage very well. It's going to cut like this. This will be released. Become another very strong radical, hydroxyl radical. This hydroxyl radical can have everything, can go do all the chain reactions they want. Okay. Okay, so once this happens, it will become what? Number 4. It will become a CH carbon number 8, 9, 10, 11. At this moment, you have oxygen there. What is this called? Alkoxy radical. Okay, now when you have an alkoxy radical, we'll talk about here, is that right? We're gonna have to write a little bit complicated, okay? Because for you to understand, we have to roll the whole thing. CH26, then goes here, we have a C, H, 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 H. I'm not going to be right here. Okay, this is going to be R1, stearic acids. This is going to be R3. This will be O. What's going to happen? They're going to have a decomposition. So this step is decomposition. What's going to be the decomposition happen? They will be cutting right here. This cut, we call it hemolytic scission. Okay, C-I-S-S-I-O-N, scission. S-I-S-S-I-O-N. Or we say beta scission. Like a knife, we cut it, like a scissor. Okay, when we cut it, become two parts. Is this part and this part. Now don't forget, this part is very long. This part is at least another 7, another 5, and then we go CH3. What's going to be this part comes from? When you cut it, this part will like this. Then the oxygen could come in later on. Okay. This part is called glycerolaldehyde. Glycerolaldehyde is a non-volatile compound. So we don't care about that one too much, because it's not going to be impact the quality of the foods. We more care about this right here. So right here, what's going to happen? We have this beta or hemolytic scission, then it will become CH, 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 CH2, CH2, 5, and then CH3. What's going to happen? This O is still here. And this bond, the residue bond, is going to attach to here. So what's going to generate? This is become C, O, H, then CH, CH, CH2, CH2, 5, and CH3. What is this guy? Aldehyde. Aldehyde will contribute to the rancidity and off flavor and the rancidity. Okay, this is a key right here. And what's the name for this? This is called 2-1-decano. If you still remember, we talked about International Union Pure and Applied Chemistry Association, chemists their name system. This UN-1, which means 1 carbon, decano, which means 10. So you add up them together is equals 11 carbon. And I mean, not like this. It is 11 carbon. So you can do 1, 2, 3, 4. 1, 2, 3, 4. This should be 6. 1, 2, 3, 4. Add 6, that's going to be 11. That's going to be 10, add 1 is 11. Okay? So that's called 2-1-decano. And that's an aldehyde. So at this moment, the aldehyde has been generated. We know it's off flavor. Now, how we tested the aldehyde? Aldehyde later on will be reacted, further reaction become formic acids. So at the end of the day, when we test the food products, how do we know the aldehyde is already generated? We are testing not aldehyde, we are testing the acid, which is formic acids. So later on, we're testing the formic acids, HCOOH, to indication there's aldehyde generated. Okay? Now here I want to mention, this guy here, when you have this one happens, it's going to be very tricky. So I'm going to using this color. Go back here, okay? This cousin, right here, we call it an alkoxy radical. because of this. This alkoxy radical go beta or hemolytic excision is one of their pathway, one of the possibility. There is others will happen. So I just gave you an example. I gave you a very brief example. I take all of these on the left hand. I wrote R1. All of these on the right hand, okay? All these, I call it R2. So what is going to become? It's going to become R1, CHO, and R2. This is the alkoxy radical. So like this. This is beta hemolytic excision, one of the pathway. What are the other pathways that are going to happen? They could have reacted with another fatty acids. Remember, alkoxy radical is very strong. Then what's going to happen? They could happen is R1, CH, O, H, and R2 and R3 radical. A new fatty acids, they will generate a new radical, which is R3, and this guy will generate. What is this guy? This is alcohol. That's why for oxidized lipids products, sometimes you smell, you like alcohol. You smell a little bit wine there, like the alcohol could generate. So this is one possibility. Another possibility that could happen is when you have this alkoxy radical, okay, when this generates, is that right? When this comes out, they could continue to react. What is going to happen? Which is R1, C, R2, and go back, become like this. Looks like the fatty acids comes back. But what kind of products comes out? It's a ketone. Is that right? That's why the ketone comes out. So these are the results could happen, which is aldehyde, alcohol, and the ketone could be happen when you have alkoxy radical generated. Okay, so here is some of the examples. Then we also want to mention something. This is the oleic acids. Is that right? And I give you one example, which has a free radical happening in the carbon number 8. And I said, when the first thing comes, become a free radical, it's going to have a isomerization, which means migration or shifting of the double bonds. So there is a possible 4 types of the oleic acids will come out. So this is oleic acids. Eight, 9, 10, and 11. Our first example of isomerization we already know is CH, 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 and CH2. And a second isomerization, you know, carbon number 8 could happen, carbon number 11 could happen. So what happened? It's right here. Is that right? That's easily understanding. So I want to mention is that if the environment do not have a singlet oxygen, is only a normal atmosphere oxygen, sometimes it will happen, the oxidation, then only 2 types of the polymer or 2 types of the isomerization, isomer will generate. However, if you have a singlet oxygen comes out, then in addition to these 2 isomers, you're going to have another 2 going to generate. What are they? So number 3 is CH2, CH. This comes out right here. And then we'll have a carbon shift. So it goes here. We'll have a double bond shift. So go here. So it become CH, CH2, like that. And then I have another one, of course. The carbon 9, the carbon 10 could be happen. Okay, when the carbon 10 could be happen. Sorry. This is not shifted right here. This carbon will shift right here. Okay, if the 9, let's do label them. 8, 9, 10, and 11. If the 9 happens, that will be go there. Okay, the shifting is goes there. Now in the 10 happens, what's going to happen? The last one. That's going to happen. So 8, 9, 10, and 11. Can you see it? So there are 4 different isomers. And these 2 is because of singlet oxygen. So overall, add up these together, we'll have 4 isomers generated. Okay, so that's oleic acids. Now, I want to give you another example. So, can you move the camera, go the other side? Just move the camera, go the other side. I'll give you another example. Yeah. This is oleic acids. How about linoleic acid? What is linoleic acid going to look like? These are skip. What are these positions? 8, 9, 10, 11, 12, 13, and 14. So, how many is it going to generate? How many different type of the isomers is it going to have? Number 1, C. Usually what we draw, we want to make sure it's easy. So we draw like this. We draw like that. This is 9, 10, 11, 12, 13, 14, and this is 8. So here are the double bonds. So first of all, I want to mention this structure. Whenever you see this in the linoleic acids, this is a very special structure called the cis 1,4 pentadiene. That's why I said the location and the structure of the double bonds will be impact the lipids oxidation, because when you have a cis 1,4 pentadiene, these type of the structure, like here, this energy level will be extremely low. This is about 79 kg per mole. That's very easy to have lipids oxidation. And they also gonna have a different type of the, 4 different type of the isomers comes out. What are gonna be are they? Let's just draw these. Okay? So, what are they? The first one, right here. This become free radical. Okay? Let me see. 9, 10, 11, 12, 13, 14. How about the second one? This is number 1. How about the second one? It will be right here. Then where is the free radical? The free radical is right there. Okay? What going to be the number 3 looks like? 11, carbon 11 is not going to happen for free radical. That will be attached by an enzyme, very typical. So we'll mention later real quick. So what it's going to be looks like, 9, 10, 11, 12, 13, 14. If it happens in 12, right here. Okay? So that's become a free radical. How about the last one? 9, 10, 11, 12, 13, 14. What going to be the last one looks like? This guy shift to here. Okay? So, then this is here. Have a free radical. Now later on, what's going to happen? OOH. OOH right here. OOH right here. And OOH right here. So, 4 isomers will have 4 hydrogen peroxide. Now, the question for you, how about linolenic acid? What is that?